Hey, welcome everybody. In this video, we're going to take a look at the 11.3 notes for Algebra 2, where we're going to take a look at properties of logarithmic expressions. And there's three main properties that we're going to focus on today. So we have what's called the product property. And what the product property says is if you have the log of the product of two values, so log of m times n, that is going to be equal to the sum of the logs. So log of m plus log of n. Now in this situation, when I wrote it, I just used the common log. But if I had log base b, each one of these logs would have to have the same base. So that's something to be aware of. So the log of a product is equal to the sum of the logs. Now you can make connections to what we talked about with exponentials here, because when we multiplied exponents, we added. So that idea of multiplication and addition still applies to logarithms. Now the quotient property works like this. If we have log of m divided by n, then that is simply going to be log of m minus log of n. Again, same idea here. All right, I used common log, but if we had any other base, each one of those logarithms would need to have the same base. Again, making the connection to exponentials, when we divided exponents, we subtracted. So that relationship between division and subtraction is still true. And the last one is what's called the power property. And that says log of some value to a power is equal to the power times log of the value. Okay, so log of m to the power p is p times log of m. Again, that same idea holds true, that if the base was anything else, then that base has to be the same. And again, this is multiplication right here. So we talked about logs being exponents. So if I have an exponent to a power, you multiply those together. That's the same thing that was with exponential things. So again, there's a connection between those ideas. All right, so those are the properties that you're going to have to learn to apply. When we start on the left and go to the right, that's called expanding. So if we're starting with log of a product and we write it as the sum of two logs, that is expanding the expression. Whereas if you started on the right side of these and you rewrote it using what's on the left, that's called condensing. And we'll be doing both of those in this lesson. All right, now some other examples that we can use. It says use properties of logarithms to evaluate the following. So we want to use the fact that the log base 6 of 5 is about 898 thousandths, and log base 6 of 8 is about 1 in 161 thousandths. We want to use those facts to evaluate the logarithms. So the first thing I have is log base 6 of 5 divided by 8. So hopefully what you recognized is that this is log of a quotient. So we're going to go ahead and we're going to apply the quotient property right here. So the first thing to do would be to rewrite this or expand this as log base 6 of 5 minus log base 6 of 8. From there, we could use the values that were given to us and just substitute in. All right, so this is going to be 0.898 minus 1.161. And if we plug that into a calculator, 0.898 minus 1.161 is going to equal negative 0.263. And that is what log base 6 of 5 over 8 is approximately equal to. All right, so let's look at the next one. So the next one is log base 6 of 40. Well, I don't have log base 6 of 40 anywhere here. So what we want to try to figure out is how do we get 40 using 5 and 8? Well, it's not too hard. Log base 6 of 40 is the same thing as log base 6 of 5 times 8. All right, so that's that product. And we're going to use that first property above that says log of a product is the sum of the logs. So this now can be written as log base 6 of 5 plus log base 6 of 8. So now we're going to add those values together. This is 0.898 plus 1.161. Plug those in the calculator. 0.898 plus 1.161 is approximately 2.059. Now, one thing you want to understand or try to think about when you're working with logarithms is, does the answer make sense? So when you look at this problem, log base 6 of 40, we want to think 6 to what power is 40? Well, we're saying that it's 2.059. In your head, does it make sense that 6 to this power equals 40? The answer should be yes, because 6 to the second power is 36. This is slightly larger than 36, so we need a power slightly larger than 2. All right, and then looking at the last example, pause the video and try to figure this one out on your own. All right, what you should have come up with is we need to find a way to write log base 6 of 125 using 5 and 8, or 5 or 8. And what pops into my head is that 125 is a power of 5. So I'm going to start by rewriting this as log base 6 of 5 to the third power. Well, when I do that, that's going to allow me to apply this third property, which tells us that we can bring the exponent in front. So this becomes 3 times log base 6 of 5. And using substitution, we know that log base 6 of 5 is that 0.898. And then we just plug that in the calculator. 3 times 0.898. And that's approximately 2.694. All right. And again, kind of the same idea. We would want to be thinking about this in terms of 6 to what power is 125? Well, we know that 6 to the second power is 36. 6 to the third power is 216. So 125 is somewhere between those, and we get a number that's between 2 and 3. So it does make sense. All right, guys, I would recommend that you guys go ahead and try the U-tries on your own. I'm not going to complete them in the video, but if you go to the website, you can find the filled out notes, and I believe they are completed there. So that way you can kind of check your answers with what they say there. All right. So now what we're going to do for the rest of this is we're going to use these properties to either condense or expand a logarithmic expression. So taking a look at number 4, again, I would suggest you guys pause the video and try to do it on your own first, especially after we do the first example. All right, so what you're going to do is notice that they're all common log, okay, log base 10. So the first thing we need to do is deal with the numbers that's in front, and those are going to move and become the exponents. So 2 log of x is log of x squared, plus 3 log of y, that's log of y cubed, and then minus 2 log of z becomes log of z squared. All right, well, what you should notice now is all that we have are basically sums and differences of logarithms. We want to ultimately write this as a single log. It only works if the bases are the same, and they are. Okay, it's base 10. So we're going to call this log. And then when you're adding, the sum of logs comes from the log of a product. So anytime the log is positive, that expression is going to go in our numerator. So x squared and y cubed are part of our numerator, and we subtract when we're dividing. So any log that's negative is going to go on the bottom. So this becomes log of x squared y cubed over z squared. Again, the easiest way to think about it is if the log is positive, this value goes on the top, but if the log is negative, like it is here, then this value goes on the bottom. All right. Again, guys, try this, pause the video before you do number 5 and see what you come up with. All right, so if we're looking at 5, we've got a combination of things. We've got some adding, subtracting. There's a power in front here. So that's the first thing I'm going to handle is this 3 that's in front. It's going to move to become the exponent. So this becomes natural log of 4 plus natural log of 3 cubed. Well, 3 cubed is 27 minus the natural log of 12 plus 6. The 3 expressions that all have natural logs, those can be condensed into a single logarithm. So the positive argument goes on the top. So 4 times 27 divided by 12. 6 is not part of a logarithm. So that's just going to be plus 6 on the outside of this. Now, you could simplify this a couple ways. Some people are going to want to just multiply 4 and 27 and then divide by 12, and that's fine. But if you're kind of doing middle math, I've got 4 on top. Well, that's going to reduce with the 12 to make it a 3. And then I know 3 goes into 27 9 times, so this is really the natural log of 9 plus 6. And that's the best answer that you can have right there. So again, the idea is if the logarithm is positive, then the argument goes in the numerator. But if the logarithm is negative, like it is here, then the argument goes in the denominator and goes on the bottom. All right, guys, again, what I would do is try the U-try on your own. I'm not going to do them in the video, but you can always go back and look at the filled out notes on the website and compare your answers. All right. So that's the examples that we just did before. Those were condensing logarithmic expressions. The next step is going to be to take a single logarithm and expand it into more, 2 or more logarithms essentially. So when you're looking at log base 7 of 3x over 5y, you've got products, but you also have quotients going on here. The easiest way to do this is if the value is in the numerator, it's a positive log. If it's in the denominator, it's a negative log. So this is actually going to separate into 4 logarithms. It's going to be log base 7 of 3 plus log base 7 of x. Both of those come from the numerator, so the logs are positive, minus log base 7 of 5 minus log base 7 of y. Those are each negative because they are in the denominator. And it really is as simple as that. Now, when you're dealing with the numerical base and argument, you do want to check to see if you can simplify them. But we would say what power of 7 is 3? That's not something we're going to easily know. What power of 7 is 5? Again, not something that we're going to easily know. All right, so pause the video, try number 7 on your own. All right, now hopefully what you came up with is you would start out with ln of 2 plus ln of x squared minus ln of 5 minus ln of y. Again, anything in the numerator is going to become a positive log. Anything in the denominator is a negative log. Well, the only thing left to do, we have not fully expanded this because of this 2. So you got to remember the property of the power property, which tells us that we can take that exponent and move it to the front. So the best answer for number 7 is going to be natural log of 2 plus 2 natural log of x minus natural log of 5 minus natural log of y. And that right there is going to be the best answer. All right, guys, same thing with the U-try. I really do think it'd be a good idea for you guys to attempt those and check your answer with the filled out notes on the website. All right, the last thing we're going to talk about in this video is the change of base formula. Now, most calculators are only going to be able to evaluate logarithms that are in either base E, which is the natural log, or base 10, which is the common log. But there's a lot of times when we have a different situation. So anytime you have log base B of some argument, all right, you can evaluate that on the calculator one of two ways. You can change the base. Well, we either need to change it to base 10, which is common log, or base E, which is natural log. And when you do that, it becomes log of the argument divided by log of the base. That's if you can change it to the common log. Or if you're going to change it to the natural log, it's ln of the argument over ln of the base. And there's different ways to kind of learn this or memorize this, but basically, when you look at the expression log base b of m is above the b. In the formula, m is above the b. So there's a little consistency there for that. All right, so what we're going to do is we're going to go ahead, guys, and take a look at these examples. And it's saying use the change of base formula to evaluate each logarithm. Give an exact answer and an approximate solution to 3 decimal places. So log base 5 of 8. Now, if you're going to ask yourself, or you're going to try to solve this without a calculator, you would think, what power of 5 is 8? Well, the only thing we can really come up with from that is it's something between 1 and 2. Because 5 to the first power is 5, 5 squared is 25, and 8 is between 5 and 25. So all we really know is it's got to be a number between 1 and 2. But that's good to know that, because it's going to help you decide if your answer ends up being reasonable or not. So what I prefer to do is, it's a little bit easier to write ln than it is log. So usually when I use the change of base formula, I'm going to go ahead and use natural log. I think in the notes that are filled out on the website, I did use common log, but I'm going to use natural log. So log base 5 of 8. Using the change of base is the natural log of 8 divided by the natural log of 5. This right here is considered the exact answer. Right? There's no approximation, there's no decimal. In order to figure out what that ends up being, we would plug that into a calculator. So if I were to just pull up Desmos here real quick. Oh, not the graphing, sorry, I want the scientific. All right, so if we were to pull that up and we were going to do natural log. So to get there, we got to go function. And you'll look here, there's 2 options. There's ln natural log and there's log, which is common log. So I'm going to do ln of 8. And we are going to divide that by ln of 5. Plug that in the calculator and we get approximately 1.292 to 3 decimal places. So we get approximately 1.292. That is your exact answer. Oh, sorry, that is your approximate answer. Sorry about that. I was reading what I already had written down. So that's the approximate answer. Now remember, we said we were expecting a number between 1 and 2. This fits. Okay? So you needed to have both of these based on the way the question was written. Now, since we have the calculator up, let me just show you real quick that if I typed in log of 8 divided by log of 5, okay? So again, an alternative solution would be log 8 over log 5. All right, if I did that on the calculator, that was one of the other options. So I've got log, so I'm going to go log 8 divided by log 5. I get exactly the same answer, okay? The key is whichever base you change it to, you have to use the same base on top and bottom. So we're either changing it to log base E, natural log, or log base 10, common log. You can't mix and match those. Whatever one you pick, use it. I mean, for most of the time, guys, natural log just becomes a little bit easier. It's a little less to write. Not significant, but a little bit. All right, so then if we're going to go ahead and look at number 9 here, we got log base 8 of 14. So if we tried to evaluate without a calculator, we're saying what power of 8 is 14? Again, it's going to be somewhere between 1 and 2. So we're going to go ahead and do natural log of 14 over natural log of 8. That, again, is the exact answer. That's exact. We're going to need our calculator to come up with the approximation. So using that same calculator, we're going to quickly go ln of 14, close the parentheses, divide that by ln of 8. And here we get about 1.269. 1.269. That is the approximate solution. All right, and we got one more. Log base 3 of 12. So we'd start out by trying to figure out, okay, what power of 3 is 12? Well, 12 is not an exact power of 3. So if we had 3 to the first, that's 3. 3 squared would be 9. 3 cubed would be 27. Well, 12 is somewhere between 9 and 27, which means we should be looking for an answer between 2 and 3. So change of base tells me to do natural log of 12 divided by natural log of 3. That's your exact answer. And then we're going to use the calculator to find the approximation. So we've got natural log of 12 divided by natural log of 3, 2.26, and then this 1's going to round up because of the 8, so we're going to call that 2.262. Sorry, that's 2.262. That again is the approximate solution, and we are done. Okay. So there are a couple more examples below for you guys to try with the change of base. Again, you can plug those in, see what you get. But guys, it's got to make sense. The answer that we're getting is the power of the base that equals the argument. So the power of 3 that equals 12. The power of 8 that equals 14. The power of 5 that equals 8. All right. And that's the idea behind those. All right, guys, watch the video as much as you need to. Pause it, rewind it, go back and look at the examples if you're still struggling with the homework. Guys, but that is what the 11.3 lesson is going to be about. So once you guys have the notes done and you've filled them out, get started on the homework. All right, guys, have a great day and have a great weekend.